Earth has countless waterways, but this single river holds 20% of the planet's entire supply of fresh water. Despite stretching across a continent and swelling up to 100 kilometers wide during the wet season, the Amazon's main artery contains no bridges. This view from orbit shows the massive force of the river's discharge. Its muddy sediment plume pushes 200 miles into the Atlantic, diluting the salt and staining the dark blue ocean waters. Yet, for all its dominance over the Earth's surface and oceans, geographers still cannot agree on where this massive entity actually begins. To find its origin, we have to look back 67 million years. A massive asteroid strike wiped out the dinosaurs and forced a total reset of the global environment. In the geological chaos that followed, shifting tectonic plates collided. The Earth's crust thrust upward, forming the towering, snow-capped peaks of the Andes Mountains along the western coast. This wall of rock severed western river flows, creating a massive, trapped saltwater sea. Over millions of years, melting glaciers and relentless rain poured into this basin, diluting the ocean and transforming it into a vast freshwater swamp. Eventually, this geological reservoir overflowed and carved a massive new path eastward. The Amazon was born from the wreckage of a prehistoric catastrophe. When that inland sea transitioned to fresh water, the trapped marine life faced a binary choice: adapt their physiology or face total extinction. Some creatures leaned into their prehistoric roots. The caiman, a massive predator resembling its dinosaur ancestors, has continuously dominated these specific waters for over 80 million years. The scale of the river also triggered extreme gigantism. Deep in the basin, you'll find the pirarucu, a heavily armored, air-breathing fish that grows up to 15 feet long. But the most distinct survivors are the ancient oceanic dolphins trapped in the jungle. They evolved into the freshwater boto, navigating the flooded forests and turning a striking pink as they age. This environment remains unique because it functions as a flooded forest populated by the adapted survivors of a vanished sea. This environment is constantly shifting. During the rainy season, the river swells to swallow human settlements and expands its surface area to over 350,000 square kilometers. At its peak, the Amazon hurls 300,000 cubic meters of water into the ocean every single second. Beneath the surface lies a hidden anomaly, the Humza River. It's a massive, slow-moving underground aquifer flowing directly parallel to the Amazon. This topographical map shows the competing theories for where it all begins. On one side, the traditional Apurimac path. On the other, the Mintaro, which carries significantly more volume year-round. Because water volume dictates the starting point, the map's fluctuations make it impossible to pick a winner. The true source moves depending on the month you measure it. A river that carved a drainage basin across half a continent still defies our attempts to place a single permanent dot on a map. The Amazon endured asteroid strikes and the rise of the Andes, but it is currently retreating from modern human encroachment. Rapid deforestation is tearing down the jungle canopy. Millions of trees that act as a moisture-retaining engine for the region are being burned and replaced by dry scars of cleared land. Fewer trees results in significantly less local rainfall, which is starving the ancient water cycle that keeps the entire basin alive. The consequences are immediate. Water levels are dropping at alarming rates, trapping specialized ancient species in shrinking pools of mud. This damage goes beyond South America. The Amazon's vast flora pulling in carbon acts as the lungs of the Earth, directly regulating the atmosphere for the entire planet. If this ancient water cycle fails, we lose millions of years of biological specialization and the primary mechanism our atmosphere uses to regulate global temperatures.